Hello everyone, welcome back to the videos about chapter 5.1 Alkanes. So in this video, we are going to talk about the physical properties of alkanes. So alkanes including cycloalkanes and alkyl group as well. So first of all, physical properties, it includes the boiling points of a species alkane. So factors that affecting your boiling point, first of all, is about the molecular size. So we will say that the molecules or the alkanes with a bigger molecular size will have a bigger surface. Therefore, it will experience a stronger intermolecular van der Waals forces. Or in other words, we can say it is the London forces, as hydrocarbon consists of only carbon and hydrogen. Okay, only London forces or van der Waals forces exist. Therefore, higher energy is needed to overcome the forces, and the boiling point will become higher with increasing molecular size. To give you a brief example, so over here, if you look at the structures A and B given here, structures B with a bigger molecular size, molecular mass, they will have a bigger surface area, strongest intermolecular forces. So for B, it will have a higher boiling point. So comparing about the size of the molecule, okay, or the size of your alkenes given, okay, higher boiling point for B. Another factors that affect the boiling point, it will be the effect of branching or surface area. Okay, the effect of branching or surface area. First, we look at the isomeric alkane. Isomer of alkane, as you learned before this in chapter 4, we have the chain isomer. Either it's a straight chain or the chain with some branching. So for alkane with comparable size, that means the size is more or less the same. The molecule with more branching has a smaller surface area. Smaller surface area result in a weaker intermolecular van der Waals forces or London force. Less energy is needed to overcome the forces of attraction. Therefore, boiling point is lower. Alright, so giving you examples over here, we have the structure X, which we have a 5 carbon straight chain carbon. And for Y also we have 5 carbon. So both structures have the same molecular size. They are called the isomeric alkane. So in this case, you can see why it has more branching. So for more branching alkane, it has a smaller surface area. So smaller surface area give you a weaker intermolecular forces and therefore lower boiling point. So for our Y, you are having a lower boiling point instead. But we can also say that for the alkane X, it has no branching, bigger surface area, therefore experience a stronger intermolecular forces. More energy is needed, therefore boiling point is higher for X, which has no branching and bigger surface area. Under the same factors of branching and surface area, we can also compare it between alkane with cycloalkane. So for cycloalkane and alkane with comparable size, that means the number of carbons are similar. For cycloalkane, it will have a planar structure. Okay, cycloalkane is a cyclic compound with a planar structures, which will have a bigger surface area, larger surface area, stronger intermolecular van der Waals forces, and more energy is needed to overcome the forces of attractions. Therefore, boiling point is higher or boiling point increases for cycloalkane. So for example, this is a straight chain carbon, which is the pentane. Okay, compare with the cycloalkane, which is your cyclopentane. Okay, the cyclopentane, which have the planar site, will have a larger surface area, strongest intermolecular forces. Therefore, we will say that cyclopentane Q will have a higher boiling point compared to the alkane, which have the similar size. Alright, so for the factors that affect the boiling point of alkane, in short, we can say that for compound with comparable size, so first of all, you need to check the size, of course. If the size is different, then the factors will base on the molecular size. But if the molecular size is the same, the boiling point will increase. The boiling point will decrease this way. Cycloalkane will have a bigger boiling point compared to the straight chain alkane, and it's bigger than the branch alkane. So the alkane with more branching will have lower boiling point. So for example, if let's say the cyclopentane C5H10, and then this is all alkane, this is all alkane C5H12, so both of these are comparable size. It's just different by 2 hydrogens only, so it's comparable, kind of similar. So for the cyclopentane, it has the highest boiling point amongst all, and then straight chain alkane, okay, and then decreases to the alkane with one branching. The alkane with more branching has the lowest boiling point. So this is the idea for the comparable size and how you are comparing between 3 types of different alkane: cycloalkane, straight chain alkane, and the branch alkane. The next physical property we want to look into the solubility of alkane or cycloalkane. So solubility, it refers to the ability of the compound or the alkane to form the bonds with the solvent. So the solvent can either be water or organic solvent. So first of all, alkane, all the alkane, including cycloalkanes, are all insoluble in water. Okay, as water is a polar solvent. So the reasons over here, alkanes, your hydrocarbons containing only carbon and hydrogen. So it is a non-polar compound. Okay, non-polar compound. It only has van der Waals forces or London forces. So alkane cannot form hydrogen bonds with the water molecule. One is non-polar, another one is polar, so they cannot form the bonding. But we can say that alkane or cycloalkanes is soluble in organic solvent. Okay, alkane is soluble in organic solvent. This organic solvent include benzene, C6H6, chloroform, CH2Cl2, or CCl4. So all of these are non-polar solvent, or we call it as the organic solvent. Yeah, so the ability to form the bond, you must mention what is the bond that it can form with the solvent. So water hydrogen bonds it cannot form, but for the organic solvent, alkane can form van der Waals forces with organic solvent. Okay, it can form van der Waals forces or London forces with organic solvent. So depends what is the solvent mentioned in the questions. So that's it for the physical property, boiling point, and solubility of alkane.